So we're going to continue our discussion of Java parallel streams internals, starting out by discussing how to configure the common fork join pool. Some of this will be a little bit of review from things that we've covered earlier when we talked about the fork join pool at the beginning of class, but I want to give a little bit of a spin related to parallel streams, and you'll see that there's quite a bit of overlap here. So first, we're going to talk about why do we need to configure the Java parallel streams common fork join pool. What's the reason we need to do this in the first place? And then we'll talk about two different ways to do this. So by default, you may recall that the common fork join pool has one less thread than the total number of cores that the Java execution environment is aware of. So Java execution environment has a way of being able to query the number of, quote, processors, which is now taken to mean the number of cores. And by default, that will return from get common pool parallelism one less than the total number of cores. So if we were on a four-core processor or a quad-core processor, then get common pool parallelism would return 3. The reason that it works this way, why it's always one less than the total number of cores, is because the calling thread, whoever's calling the stream to do the terminal operation like collect or toList or whatnot, that will pitch in and work with all the other cores that are part of the common fork join pool. So even though there's 3 in the common fork join pool, the calling thread is always included and it pitches in and runs. So therefore, by default, we can have the total number of cores be used to run a parallel stream, unless you do something to the contrary. However, the default number of fork join pool threads, the common fork join pool threads, may not be adequate. Why might that be the case, you may ask? Well, consider an app that's going to download and process images in parallel. And you are aware of such an app because that's what you're doing for your assignments. I also have an example of this that we'll take a look at later called the Image Stream Gang case study, and it's pretty cool. But it takes a bunch of images and processes the images much like your assignment does. However, problems may occur if you try to download more images than there are the number of cores. So let's say, for sake of argument, we have 4 cores. We're trying to download 10 images. The problems here could be either you're going to underutilize the processor cores, and the reason for that, of course, is that if you only have 4 cores but 10 images, once the 4 cores are used to start downloading images, those threads in the pool will be blocked, and even though there's more images that could be downloaded if there were threads available, instead they're all blocked downloading the 4 images. And remember, when a thread blocks on I/O, that basically means that it's stuck, if you will, until the I/O completes. So what we really need, and the other problem is we don't have that in this case, but you could also end up with deadlock situations as well. I won't go into that use case at the moment. So what we'd like is some way to be able to add some additional threads so that waiting threads, waiting downloads, are going to be able to be serviced by fork join pool threads, common fork join pool worker threads. Now, there's a couple different ways to do this. As you probably recall, one way to do this with parallel streams is simply to set this rather verbose system property, java.util.concurrent.forkjoinpool.common.parallelism, and set that to be a larger value. So you could set it to be 8 or 10 or whatever the right amount is. The problem there is it's rather hard to estimate the total number of threads to set. You'd have to know in advance how many images were going to be downloaded. Sometimes you would know that, sometimes you wouldn't. The other problem is setting this property affects all the parallel streams within a process. So if you make it too small, then there'll be other threads that are in other parallel streams that are not going to be able to run in parallel. If you set it too large, you'll be wasting resources unnecessarily. And another complexity is you can only change this property before the common fork join pool is initialized. And the thing to remember, if you look carefully at how fork join pool works, it's a singleton-like mechanism. It's not a singleton, but it's like a singleton in the sense that it's lazy. And the first time the fork join pool is accessed, it'll initialize itself. So you got to make sure you call this system property setting before you use it the first time. Therefore, a better way to go, usually, is to use the manage blocker mechanism. And as you may recall from our earlier discussions about fork join pool and the common fork join pool, you can use this to temporarily add worker threads to the fork join pool. And the nice thing there is it does it on demand. So as more blocking operations occur, the fork join pool compensates by spawning new threads, and those threads are used for a period of time, and then if they are unused for a period of time, they are going to be terminated and they'll go away. So you don't utilize resources unnecessarily for too long. This is particularly useful for behaviors that block on I/O and or synchronizers, thereby making parallel streams useful for non-compute bound operations. There's a common misconception that fork join pool, and by extension the common fork join pool and parallel streams and so on, only work for compute bound tasks. That is incorrect. That is a misconception that is incorrect. You can use it for I/O as long as you use the managed blocker interface. And the other nice thing about this is you can use managed blockers for any type of fork join pool, not just for the common fork join pool, although in the context of parallel streams, that's where it really matters, because that's what we're thinking about here. So that's a quick overview of the mechanisms by which we can configure the common fork join pool.